In today's video, I will show you how we could use the GPIO of the MBED and also the way how we can connect analog sensors to the ADC of the module. Although there are quite a lot of IOs that are available from the Cortex-M microcontrollers, but if you look at the module of the MBED, basically you only have the IO from P5 up to P30. The pin 5 up to pin 30 on the MBED module doesn't represent the ports that we discussed about on the ARM GPIO. Therefore, before we can do any assembly program to interact with the GPIO of this MBED module, first we need to figure out for each of the pin output which port and which pins the ARM microcontroller that is actually connected. So to simplify the connection between the pin on the MBED to the Cortex-M microcontroller, I already put the file link in the description so that you can download the tables while you are watching the video and do it together, so that you can make use of the table for your future project. The first thing we need to do is that, for example, if I decide to connect something, for example an LED to pin 5 on the MBED module, so I need to figure out what is the port or pin that this P5 representing. If I refer to the tables, there is a value that you can find for ARM, so which is what we have learned previously, port 0.15, port 0.11 and so on. And also there's a row of data for the MBED. The number on the MBED row represent the P numbers that MBED provide for us. Take example on this case for pin 5. So if you refer to the table, the pin number 5 is actually connected to the ARM microcontroller port 0.9. It's important for us to know what is the port number and the related pin in the microcontrollers, because when we are doing the assembly language, we are using the port 0.9 instead of P5 as provided by the MBED module. And also today I would like to introduce a new register which is called pin select. So there are a few pin select that you can find inside Cortex-M. So you have, for example, pin select 0, you have pin select 1, pin 2, pin select 3, and lastly pin select 4. Purpose of pin select is to tell our microcontroller for each of the particular pin that we would like to use, which function that the pin is supposed to behave. So for example, there are 4 different functions that you could assign to a pin from the microcontroller itself. For example, function 00, the pin will behave as the GPIO, basically means digital input or digital output. So if you look carefully on the table, for example, some of the pins, there is a second function, function 01 in pin port 0.11 and port 0.10 is the TX and RX for the UZAT interface. For the analog to digital converter that we learned in the previous video, if you would like to connect any analog sensors to the microcontrollers, you can find there are 4 analog input pin in the pin select 1 registers, the analog input 0, analog input 1, analog input 2, and analog input 3. For analog input 0 is physically connected to port 0.23, and analog 1 is port 0.24, and so on. In order for us to tell our Cortex-M microcontroller that for port 0.23, for example, and we would like to use it as an analog input instead of the digital input output, we have to set the value of function 01 instead of 00 to the pin select 1 register. And at the same time, we also can look at pins that actually routed to the module on the MBED itself. For example, analog input 0 is actually available at P15, which is the P15 that's come with the MBED module. If that's case, for example, if I have a temperature sensors, and I need the analog input to interface with these analog sensors. I have to select pin 15 in my MBED module. If you look at the table, basically all the pins, you can set it as a GPIO, but not for the ADC. So there are only 4 ADC input pin available at pin select 1 for the port 0.23, port 0.24, and port 0.25, and port 0.26, which has been physically connected to the MBED module at pin 15, pin 16, pin 17, and pin 18. In case you have few of the analog sensors, this is the analog pins P15, P16, P17, and P18 are the only pin that allow us to connect any analog input sensors. But of course, the rest of the I/O start from P5 up to P30. It can behave as a GPIO. For any digital input or digital output, you are free to choose among them. Similar to other registers, pin select registers also is a memory map I/O. So memory map to an address, for example, pin select 0, the address is 4002 and C000, and for pin select 1, 4002 C004. And once you have figured out your circuitry, and you know which of the pin that you would like to use as GPIO and which of the pin you would like to use as ADC, you could populate the 2-bit value. For example, if you need to use a pin select 0, or you can populate the value for the 32-bit for pin select 1, and you could use the store instruction to move the value that you have figured out into the address of the pin select 0 and the pin select 1. We'll look into how we could do some simple project using the MBED ARM microcontroller modules, and step by step how we could figure out which is the input or output pin we would like to use, and including the program in assembly language, how we could complete the solution that we are looking for. So let's say we would like to design an alarm system for our door to detect whether the door is open or closed. The first thing we need to do is to determine how many input and how many output devices that we would like to use in this system. Let's assume we only have one input devices, which is a switch that used to monitor the status of the door, whether it's open and closed. And we will have 2 output devices. One is the LED to indicate the status of the switch, and also a buzzer that makes noise when the door is open. In order to simplify the solution, I will assume all the devices are using only GPIO rather than analog input. The next thing we would like to do is to determine which of the pin in the MBED module that we would like to connect all these devices to. Since we are only using GPIO, we are free to choose any of the pin that we have on the MBED module. So let's assume my switch is connected to P5, my LED is connected to P6, and the buzzer is connected to P7. Then based on the template that we have, when we're looking at the MBED module, the pin 5, pin 6, and pin 7 can be found there. After we have located where is the pin 5, pin 6, and pin 7, we can determine what is the port number is being used in the ARM microprocessor itself. For P5, which is port 0.9, for pin 6 is port 0.8, for pin 7 is port 0.7. And since all the pins that we chosen are located at port 0 in the ARM processors, we only need to set the value for the pin select 0. Also, since all the input output are using GPIO function, which is bit function 00, so all the value from bit 14 up to bit 19 should be 0. And of course, the rest of the I/O we are not using in this project, so we could just fill in 0 for the rest of the bit after we have figured out the value for the pin that we are using, we can determine that pin select 0, the value has to be 0x, 0, 0, 0, and 0, 0, 0. And then the next thing that we need to figure out would be the FIO 0 direction registers to tell my microcontrollers which of the pin or which of the bits in the FIO direction register the value has to be 1 and which of the bits the value has to be 0. Determine whether devices that will be connected to all these pins, which one is output and which one is input devices. So as what we have covered in the previous video, if this is the input devices or you would like to make it as an input pin, the value we have to put in is 0. And if our devices is the output devices, the value will be 1. The first devices that we have, which is the switch, is actually connected to the P5 of our ARM module. And just now we have determined that the ports is port 0.9 in the ARM microprocessors. Then the second devices is a LED, which we connect to pin 6 in the MBED module that is mapped to the ARM controller itself is port 0.8. And lastly, we have the third devices, which is the buzzer. We plan to connect it to pin 7 of MBED module. The pin 7 of the MBED module is connected to port 0.7. And since switch is an input devices, the value we need to write into the FIO 0 direction for bit number 9 is 0. LED is output devices, which is connected to the port 0.8. And for the bit number 8, the value has to be 1 because this is the output devices. And lastly, for buzzer, which is at port 0.7, similar to the LED, buzzer is also output devices. So the value for the FIO direction registers for bit number 7 has to be 1 as well. So with that, I can figure out what is the value I need to put in into FIO direction registers, assuming we are not using any more on the rest of the pin. So I could just simply fill in 0 for the don't care, and then we can determine what is the hexadecimal value that we need to transfer or store into FIO 0 direction registers. So after this, we can determine that the value that we're supposed to put in into FIO 0 direction registers would be 0x 0, 0, 0, 0. And the reason why this is FIO 0 direction registers because all the pin that we're using is all located at port 0. Next, we have to determine where is our switch is located and how the value can be read from the FIO 0 pin registers. In this case, our switch is connected to port 0.9. When we go to the FIO 0 pin registers, bit number 9 is where the value of our switch going to be located. Let's assume the switch is going to give us value of 1 when this is open, and it will give us a value 0 when the door is closed. We can actually populate the tables to figure out what will be the value that we can read from FIO 0 pin registers during these two conditions, open and close. During the open condition, the bit number 9 in the FIO 0 pin register at number 9, the value will be 1. Then we could calculate what is the masking value that we would like to use to filter out the FIO 0 pin registers so that we can actually compare what is the value we have at the bit number 9. If you convert the value into a hexadecimals, so assume the rest of the bits is 0, then we will have, so the mask value that we can use to filter out the FIO 0 pin registers would be 200 in hexadecimals. And lastly, in order for us to control our output devices, which is LED and buzzer, we need to determine what will be the value we should put into FIO0 set to turn on the devices, or FIO0 clear to switch off the devices. So the bit that we need to set to 1 is determined by the bit where the LED and buzzer is connected to. So in our case, which is bit number 7 and bit number 8. And we would like to our system to behave like both of the LED and buzzer going to turn on or switch off at the same time. So in order to turn off both LED and buzzers, we have to put 1 for both bit 7 and bit number 8 in order to switch on the LED and buzzers. Then the hexadecimal value that we need to write into FIO set registers would be 0, 8. We start the code by loading all the address for our GPIO into our registers. Register 0 will have the value of 4002C000, or the address that is allocated for pin select 0. So after we have loaded the value into register 0, we have 40 into R0. Then we wrote the address for the FIO 0 direction into R1. After we have execute the instruction, R1 will have the value 2009 C0 and 00. And then we wrote the address for FIO 0 set registers. The value is 2009 C018 into R2. And then we have the value, the address for FIO 0 clear register, and the address is wrote into R3. And lastly, we have the last address for FIO 0 pin registers, and the value is put inside register 4. Just now we have determined the value that we need to put inside FIO select registers, and the value is 0. So we need to store 0 into 4002 C000. The way how we do it is we load the value 0 into R5, and then we store the value that we have in R5 into the address pointed by register 0, happen to be our pin select 0. After that, we need to put the value 180 into FIO 0 direction to tell our microcontroller which of the pin that we need to use it as an input, and which of the pin that we need to use as an output, and the value is 180 in hexadecimal. So we can repeat the same process. Load into R5, the value is 0x180 in hexadecimal, and store the value in R5 into the memory address, and the address is given by register 1, which represents FIO 0 direction. Once we have done the configuration to determine which of the function that we need to use for all our GPIO, and also which of the direction, or in other words, which is input or which is output devices for all the GPIO that we deselected, we can start to develop the logic of our alarm solution. The first thing we need to do is to read the status of our pin. The way how we do it is by reading the memory address given by the FIO 0 pin registers. I read the value from the address given by R4, which is our FIO 0 pin registers, into register 6. The value we have now on register 6 holds the current status of our switch, whether it is 1 or 0. Just now we have determined what is the masking value that we can use to filter our FIO 0 pin registers. The value is 200 in hexadecimals. We can first load 200 to register 5, and we use an AND operation between our register 6, which is our value from FIO 0 pin registers, and with register 5, which is our masking value. And lastly, whatever value we have in register 6 are the status of the switch, whether it's 1 or 0. With that, we can easily compare register 6 with 0. When the value is 0, the switch is closed. If the value is 1, the switch is open. In this case, if the R6 is equals to 0, means the switch is closed. We can branch if this is equal to a close, where the close will be somewhere there, to instruct our processor to continue to read the status of the switch into R6 and repeat the filtering process and compare whenever the switch has been changing from 0 to 1. So once the switch has been opened and the value we got in R6 is no longer equals to 1, then we have to figure out what is the code to switch on our LED and our buzzer. And as what we have figured out just now, in order to set or turn on both LED and buzzer at the same time, the value we need to put inside FIO set registers will be 180 in hexadecimal. So we need to store the 180 into the FIO set registers, which is at R2. But before we can do that, we need to put the value into register 5 first. And only with that we can store whatever value we have register 5 into the memory address given by R2 or our FIO 0 set registers. So with that, the LED and the switch should turn on as what we expected in our design. And with that, this is the solution for our simple alarm system. Of course, there are improvements we can do on the code itself, but this is the most straightforward solution that we can do at this short time. So hopefully you learned something today, and I will see you in next video.